Hi dear students, let's see this question that came in KVBY 2018 SX Part 1 Physics paper. So basically here we are throwing two balls, one of mass m and other of mass m. Let me go to the ballpoint mode. Yeah, so one of them is of mass m and the other is of mass 2m. With the same initial horizontal velocity v naught from top of a very tall tower. Apart from gravity, the ball also experiences a drag force, which is, of course, the proportional to the velocity of the ball. So we have to find that which of the ball is going to hit, like which of the ball is going to go farther away from the tower, or whether the balls are going to, hit the same spot. Okay, balls will hit the ground at the same time. This, of course, will not be correct because in the y direction, both of them will have different accelerations. Gravity will be same for both of them, but since the masses of the balls are different, so we can say that ball will have different accelerations in the y directions, and hence they will not hit the ground at the same time. But let's investigate whether the balls are going to hit the same spot, or whether one of them is going to go farther away from the tower. Okay, the tower is very tall. Now if you let's draw the tower first. So if this is the tower and the ball has been thrown with velocity v naught, so at any instant, let us say the velocity vector is pointing in this direction, v. Okay, so in the x direction, the x component of velocity, let us say, is vx, right? Vx. So we can say that the force in the x direction will be minus kvx, right? So this minus kvx will be creating the x retardation. So we can write this as minus dvx by dt, correct? Similarly, if you want to write about in the y direction, so we can say that in the y direction, force in y direction will be mg minus kvy. This is the force in the y direction. So we can write mg minus kvy will be is equals to m dvy by dt. Okay, so from here you can see that dvy by dt will be equals to g minus kvy by m. So of course, this g is same for both of them, but k by mass, k is also same. If both of them started with zero initial velocities in y direction, so this factor, the moment they start gaining some velocity in the y direction, this factor will be different. K, because one of them has got mass m and one of them has got mass 2m. So the acceleration in y direction is different, and displacement of both of them in y direction will be same. So time of flight will, of course, will be different. Now we will investigate the x. So this Vx can be written as dsx by dt, which is the displacement in the x direction, will be is equals to m dvx by dt. So if you integrate this, and dt will be cancelled out. Initially, the displacement in x was 0. At that time, the all velocity was in the x direction itself. So which we can say v naught. Finally, when the velocity in x will become 0, because the tower is very very tall, so we can say that eventually it will effectively move in y direction only because the tower is very very tall. So it will effectively gain whole velocity in y-axis. So dvx, vx will become 0. Okay, and we can say that by that time displacement in x would have become sx. So if you see, this becomes k into sx will be is equals to minus mv naught. So from here we can say that sx becomes mv naught by k. So you can see that v naught is same for both of them, k is same for both of them, but mass, of course, the mass of second ball is twice the mass of the first ball, and hence the displacement of the second ball will be almost twice the that of second ball by the time they hit the ground. So we can say that they will hit. So heavier ball is going to hit farther away. So the heavier ball is going to hit farther away from the lighter ball. Option A will be the correct answer in my opinion. I hope you would have understood the solution. That's it. Thank you.